Welcome. Thanks for joining me for part one of a new series covering equipment lifecycle management with design methodology. This will include an overview of lifecycle costing in an effort to capture the value add of performing an equipment lifecycle costing analysis. Equipment lifecycle management is a methodology for managing equipment throughout its lifespan from design and development through the end of life. It's often a post-production strategic planning tool. It's used for the long-term predictive analysis of equipment and assets. The value add is that a lifecycle projection and costing analysis of your equipment will help your company predict future overhaul, retrofit, or recapitalization expenses well ahead of failure or degradation, which will in turn minimize expenditures and optimize usage in the long term. Lifecycle management should be scalable and tailorable to your specific equipment types and variations, as there are no cookie-cutter solutions to managing your equipment's lifecycle. The most optimal method for lifecycle managing is to build your plan into the design stage of equipment or product release. The Design for Sustainability, or D4S process for lifecycle management, is the most effective way to predict lifecycle events and project failure. It does, after all, make more sense to preempt potential impacts at the design stage. It's just not commonly done. There is a tremendous body of knowledge in sustainable design for buildings and structures that front-load environmental concerns that balance cost with modernization. The National Institute of Standards and Technology, or NIST, has volumes of top-notch research that describe lifecycle costing principles that follow best practices, such as Leadership in Energy and Environmental Design, or LEED. Many government organizations, such as the GSA or the General Services Administration, have been mandated to follow LEED design in accordance with Executive Order 14057, which mandates a net zero operational footprint by 2030. Enhanced equipment design is less restrictive than with structures and far less evolved. For the purpose of this discussion, we will focus on equipment post-production lifecycle management. Initially, there will be little or no data from which to begin the mapping process, meaning the original equipment manufacturer, or OEM, guidance will be the primary basis for your analysis early on. Most OEMs do provide general guidance and will estimate an average life expectancy with wear-out dates based on average wear and tear under normal circumstances. To get started, I would recommend performing a macro assessment of your equipment's current state along a serviceability threshold map. If we follow the U.S. military's lead, we will see that they have four commonly understood thresholds, and that is serviceable or new, maintainable, some maintenance required, unserviceable and repairable, that means routine maintenance is required, and finally unserviceable and unrepairable, or end of life. I have always found that this categorization of equipment states was very helpful, whether it be applied to wheeled vehicles, heavy equipment, or even more sophisticated machinery. Once all of your equipment is generally assessed and mapped against these thresholds, you will then be able to prioritize your in-depth analyses effort and gain a deeper understanding of your overall status. You can then add layers and build upon the map with additional thresholds such as requisition thresholds and technology thresholds. I'll get into that later. These would be used with equipment such as computer hardware, UHF equipment, and other rapidly evolving components. Start with analyzing the Category 2 or even the Category 3 equipment if you have it, and begin the arduous task of collecting data. You will want to assemble a broad range of data early on to begin the analysis. Most importantly, focus on performance historical data. Here's a complete list of key inputs for consideration as you gather data. As we discussed, OEM end-of-life predictions, performance historical data, prior failure rates, repair and replacement data, wear and tear industry trends, form factor considerations, increasing performance requirements affecting degradation rates, hardware support termination for computers and electronics, warranty information, diminishing manufacturer sources and material sources, or DMSMS. And once again, a lot of this is subjective, but I would recommend harvesting all data relative to the equipment being evaluated. Nothing should be left out. My thoughts are that no data is irrelevant, especially early on in the process. It may not always be evident why a particular data set may be useful, but it should be collected nonetheless. The amount of data will then help you determine how to shape your full analysis and make the projection. Obviously, if you have rich data sets spanning several years, your projections will be more accurate and more thorough utilizing a lifecycle costing methodology. One of the first lifecycle management projects I was assigned years ago involved the analysis of several end items and electronics that spanned over several years. It was thought that we owed the shareholders an in-depth understanding of our equipment's historical trends. You can see here that even the capture document in Excel spreadsheet was quite detailed and involved a calculated lifecycle cost, which I'll explain in the next segment. If you're having difficulty gathering data and have little to no OEM guidance, you may want to begin writing a narrative that is centric to replacement based on wear and tear usage with extrapolation that is aligned with warranty expiration, because that's going to be your primary guiding document. Beyond economic repair, or BER, is a very direct and almost obvious methodology, but not optimal for long-term projections. The most common analogy is the car transmission analogy. If your 2002 Honda Accord has a Kelley Blue Book value of $3,200 and your transmission goes out and has an estimated replacement cost of $2,800, well, that car is a good candidate for end of life based upon a very simple BER assessment. You would have to establish the criteria for qualification based upon your company's strategic maintenance budget and internal repair and replacement policy. Your goal should be to apply as many of these evaluative strategies as possible in order to make the most accurate and lengthy projection possible. One of the most complex and thorough methodologies is the lifecycle costing analysis. Typical parameters include depreciation, inflation, maintenance, repairs, and obsolescence. All of this is applied in a formula that helps produce a lifecycle cost by year expressed in dollars. This product is then measured against your company's annual operating and maintenance costs, or O&M budget. The product should be displayed in a multi-year scatter chart that represents both the projected lifecycle cost along with the operating and maintenance costs. The replacement year is the year that O&M costs reach or exceed lifecycle costs. This methodology and formula are available in the National Institute of Standards and Technology, or NIST handbook. While easy to get lost in the data, the important thing is to begin the build of a narrative that is broad and intuitive. If data is not readily available, actually write out the narrative and collect anything relative to the equipment being evaluated. In the next segment, I will discuss what to do with the data once you have it in the formulation of the lifecycle cost by end item, and add some granularity to this discussion. To give you a snapshot, a few years ago I performed an analysis on a 10,000-pound 55-foot telehandler forklift, and this equipment was mapped out over an 8-year period. You can see here at around mid-2025, it was projected that this equipment may reach EOL candidacy based on an ascending lifecycle cost that would exceed the O&M costs. Now, with this information, the CFO can go ahead and add this equipment to the Q4 budget. There's the value add right there. That's the deliverable. The scorecard is one of the tools used to analyze equipment in a risk assessment framework through the use of a raw score. The raw score is acquired from measuring the equipment against the input criteria, and then the score is placed along a serviceability continuum seen at the bottom of the chart. We'll get into this process in detail in the next segment. Thanks for watching today. See you next time.